Well, good afternoon, everyone, and it's great to welcome nearly 350 people to our presentation this afternoon from a wide-ranging cross-section of the construction industry and other related sectors. My name is Gordon Reid. I'm Kier Construction's Regional Business Development Manager in Scotland, and I'm privileged to be able to chair this discussion today. Our three 15-minute presentations follow on from the various discussions at COP26 over the last fortnight, and will dip into three important aspects of how the built environment can become a sustainable industry. Our presenters today are Jo Gilroy from my parent company, Kier Group, Stephen Long from Scottish Futures Trust, and Jonathan Hines from Passivhaus Trust. Our first speaker is Kier Group's Head of Sustainability and Environment, Jo Gilroy. Jo has already presented this week at COP26 and will describe Kier's route to net zero and how Kier can add value to clients' decarbonising agenda through our Building for a Sustainable World strategy. Stephen Long is an Associate Director with Scottish Futures Trust and will discuss how Scotland's Learning Estate Investment Programme is delivering a sustainable environment for our young learners. Our final speaker is Jonathan Hines, Chair of the UK Passivhaus Trust's Scotland Committee, and he will discuss aspects of decarbonising the current built environment following Enerfit principles, with two projects his architecture firm, Archetype, is involved in. There will be a 30-minute Q&A at the end of the three presentations. If you'd like to raise a question, please make full use of the Q&A function during the various presentations, especially for Jo, who unfortunately will need to leave us at 12:45. At this point, I will now hand over to Jo.
Thank you very much for that warm introduction, Gordon, and welcome everybody, obviously, to today's webinar. I'm just in the process of sharing my screen, and as Gordon has elaborated on, I'm going to be talking to you about, what Kier is doing specifically around our net zero pathway. And in particular, what I would like to do is to start by sort of setting the wider context that I think is, quite relevant to a number of the conversations that have been happening at COP this week. So first of all, in the interest of, again, setting that context, what does sustainability mean at Kier? And we have really embraced the fundamental principle of the definition, which is sustainability is a mindset. And it is a mindset that it is critical that every individual and business professional adopts, regardless of what their role or function is, because it is a mindset that says that I'm going to go about my day-to-day business, my day-to-day working activities, accounting for and balancing the three critical features no business can survive without, and that is having a resilient environment, a resilient community, both our internal community and our external community, so our customers and our suppliers, and resilient profits. And sustainability simply says that if you keep all three of these things in balance and you don't allow one to dominate another, you will have a healthy and fundamentally resilient business. We have embraced the principles of the United Nations Sustainable Development Goals, which you can see on the screen here. And some of you will be familiar with these goals. And I'm sure that some of you will have seen these goals represented in a very linear fashion, where they look like effectively a pick and choose menu. But the goals themselves were envisaged to be enacted in a very specific order. Firstly, effective sustainability strategies should aim to create a stable biosphere. And that's the bottom donut that you can see, where companies not only understand, but actively seek to mitigate and reverse the damage that their operations have on life on land, which is goal number 15. Life below water, goal number 14, access to clean water and sanitation, goal number 6, and then the one that we all know, climate action or the net zero agenda, which is goal number 13. Once you have a stable biosphere Only then can you have a stable and healthy society, and only then can you have a stable and healthy economy. And you know, for me, the global pandemic has really thrown into sharp focus what happens when you don't have a stable biosphere, which is the health of your society is compromised, and then the health of your economies are compromised. So we structured our whole framework around having that healthy biosphere piece. So for us, we recognise that the SDGs are interconnected, interlinked, and that our activities must start with those biosphere goals. And crucially, that our responsibility doesn't just stop at the site gate. This is very relevant where we talk about Scope 3 that I will come to in a moment. But we must consider the full life cycle impacts of our activities down through our supply chain and down through our value chain. So that's just to give you a little bit of the wider context of our framework and how we are seeking to take that balanced approach and focusing on driving positive activities through these areas that you see on screen, which are very much based on those UN Sustainable Development Goals. But the one that I'm going to focus on particularly today is our net zero commitment. Because there's obviously been a lot of conversation last week and this week around COP26, and the draft agreement at the moment is trying to encourage the 200 companies and countries in attendance to commit to publishing more ambitious carbon targets by the end of 2022. So at the beginning of the new decade, which was very much heralded as the decade for sustainable delivery, but so far has very much heralded in other things since 2020, we began by saying, right, we know we must achieve net zero. We're not 100% sure what that looks like at this stage for the business, but we know that we must make a solid commitment and we must nail our colours to the mast. So we committed to a net zero target, very much in line with the government legislation at the time. So we committed to achieving net zero carbon emissions across our own operations and our supply chain by 2045. But today I'm going to put a bit more detail on those bones for you. So firstly, it's really important for us to highlight that when we say that we are going to achieve as an organisation net zero for our carbon emissions, we are not just talking about the carbon itself. We are talking about all greenhouse gas emissions, and there's been a lot of conversations recently around the impacts of methane, with again the COP26 draft agreement including a commitment for countries to cut their methane emissions by 30% by 2030. Why? Because a lot of us on this webinar will know that methane is considerably more potent as a greenhouse gas than carbon itself. So for us, it was about saying we must make sure that through our activities we measure the impact of all these gases if we have operations that are emitting these. Secondly, what we did was we said, right, the carbon landscape is quite complex naturally, and it's being made more complex by having quite a lot of chefs in the kitchen at the moment, all carving up various carbon pathways, all taking a slightly different approach. We've got many organisations that are drawing different scopes around what they are measuring, different scopes around what they are seeking to exclude at this stage for various reasons, or include as the case would be. So for us, we decided actually it's about being very clear with our customers as to what we are going to include, and if anything, what we are going to exclude. So we looked at the scopes themselves, and there are 3 scopes of carbon: scope 1 and 2, that specifically relates to an organisation's direct use of gas, electricity and fuel, and the subsequent greenhouse gas emissions that come from using those resources. And then we have scope 3. Scope 3 very much being the elephant in the room, and for any organisation, scope 3 roughly accounts for about 80% of their overall carbon footprint. So you can't really aim to achieve net zero without tackling scope 3. And within these scopes, as you can see on the screen, there are a number of categories as well. And we have committed as a business to tackling all of those categories. And I think this is very relevant when it comes to Scope 3. For a lot of businesses and for a lot of our customers, Scope 3 is the unfamiliar territory, because a lot of the carbon accountancy around Scope 3 is only just now being unpacked, and only just now are the effective mechanisms around how do we effectively measure the embodied carbon of the materials and the products that we source. You know, when we talk about measuring the operational carbon that is emitted from the product that we've built, whether it be the school or the road or the government building, when we talk about measuring the carbon emissions that are emitted from that product over its lifetime, where do you draw the boundary? So how long do you assume that asset is going to run for? So a lot of this methodology is currently being unpacked at the moment. But what was critical for us was that we were transparent in saying that we would measure all of it. So what you can see on the screen at the moment is called the NCORD protocol. It's an industry standard for mapping out not only your scopes of carbon, but the categories within those. And what we have done is we have added to the NCORD protocol. So what we have created is NCORD Plus, because we identified that within the protocol itself, we had certain activities specifically around the use of carbon emissions that come from the use of both portable and grey water for our utilities business that wasn't necessarily being captured by the NCORD protocol as it was. So for us, when we say we're going to achieve net zero, it's for all of it, and for all of it by 2045. What does that look like in practice? So to start with, we have focused on our scope 1 and 2 categories because that very much is the low-hanging fruit within the business. And we ran a number of climate scenarios. So looking at what would our pathway look like if we had a 2.5 degree warming, what would it look like at 2 degrees, and what would it look like at 1.5 degrees? Now we took the decision to align to the science-based targets for a 1.5 degree planetary warming, and that's what you can see on the screen in front of you. These are the actual reductions that we must achieve in order to hit net zero for scopes 1 and 2, and we're going to do it by 2039. Some of you will be on this call thinking, why 2039 and why not 2030? The reason for that is because we are aiming and committing to doing this without offsetting. When we look at scope 1 and 2 today and the technology available for us to be able to eliminate emissions from the fuel, gas and electricity that we use in our own business operations, we really don't have an excuse anymore to rely on offsetting. Offsetting for me is about kicking the can down the road, and I think that there has been an awful lot of scrutiny, quite rightly so, around various offsetting schemes. One's, you know, when organisations commit to offsetting, what does that mean in practice? A recent report by Oxfam highlighted how, if we take Nestlé as an example, if Nestlé were to actually offset to the extent that they've committed to do, they would have to build and create a forest the size of Denmark. So you can imagine the scale of land that a construction business would require in order to effectively offset. We worked out that if we were to take offsetting off the table, 2039 allowed us to hit a realistic deadline while still maintaining a 1.5 degree pathway, and that for us was critical. So for scopes 1 and 2, 2030, we will be net zero by 2039. And for those of you on the call who are particularly carbon literate will know that by taking offsetting off the table, that's no longer a net zero target. It is in fact an absolute zero target. So I'll before I get asked that as a question, I'll cover that point there. So what does that look like for the construction business in particular? Well, this is the challenge on the screen that we have proposed to the business as to how they need to start to reduce their carbon emissions. Each of the businesses within the Kier portfolio have been set their carbon reduction targets for FY22, which we are actively measuring on a quarterly basis, not just by recording the tons of carbon in our business, but also crucially recording the cost of carbon to our business. We were very keen at the beginning of this journey to develop commercial metrics around our carbon success. Why? Because it allows the businesses to develop those business cases more effectively around investing in low carbon technology solutions. Within the pathway itself, we have a number of additional interim targets. So although our overall absolute target for scopes 1 and 2 is 2039, we do have an interim target for 2030 that we will have achieved a 65% reduction in our 1 and 2 emissions over the next decade. We have committed to a number of international and industry pledges, such as the climate groups EV100, EP100 and EV100. So for us, that means that we will have net zero offices by 2030. We will be using 100% renewable energy by 2030. We will have a 100% electrified fleet within 2030. We will have on-site net zero carbon, so that's our plant equipment that we use, by 2040. And as I've already said, we will have aligned to the 1.5 degree science-based target. What that means in principle is that, again, by 2030, we are going to have reduced the embodied carbon of the materials, products and services that we source by at least 40%. So certainly none of this is for the faint-hearted. There is a lot of ambition here. And we have set these targets using 2019 as our baseline year. We drew a new baseline because since 2014 in the business, we have already had tremendous success in reducing our carbon emissions by 54%. So we decided to reset the baseline in order to continue to build on that success. Just actually, before I leave this slide, I will mention our primary focus this year is twofold around carbon. Firstly, delivering on the FY20, so the financial year 2022 reduction targets that we have committed to, but also crucially in measuring in detail the scope 3 categories that I talked you through before. So we will be publishing to our internal and external stakeholders at the end of our financial year this year, which is June next year, our scope 3 baseline number. What we will then do is add that into our climate modelling pathway in order to understand what reductions we have to make across all of those scope 3 categories. And ideally, the ambition is that we will then have the evidence and the data to demonstrate that we can move our 2045 final deadline for scope 3 forward. This will hopefully allow us to keep in line with the more ambitious carbon targets that the government may be signing up to in a matter of weeks. So what does that mean from a practical point of view? What are we doing around scope 1 and 2? Well, none of it, to be perfectly honest, is particularly technical. What we have to do is be as efficient as possible on site as we can to eliminate and reduce as far as possible those emissions. And a lot of it does come down to behaviour change. So we have 3 areas of focus: our fleet, our sites and our offices. Within our fleets, it's very much the transition to the electric vehicle side, but where we do have barriers to the practical application of that. So, for example, if we have members of Kier staff who currently have a company car, but say live in an apartment block, and so they don't have ready access to charging facilities, what we must start with them as we wait to transition them to an electric vehicle is very much that behaviour change piece, making people aware as to the way in which they drive does have a tremendous impact on the amount of fuel that their vehicle consumes and therefore the carbon emissions that it emits. Within our sites themselves, we are realigning the way and developing new tools for measuring the way that we size the generators that are required for those projects. We have brokered new deals with renewable energy providers so that we can actually start to switch over all of our sites to 100% renewable energy capacity. And across the business, we are trialling new innovations around the electrification of mobile plant and testing where that is feasible or where actually there is a bit of a technological delay, and factoring that into our pathway as to when we can start to bring that electrified plant equipment on board. And within our offices, there is a big programme of works underway about understanding which buildings that we are currently tenants in, whereby we do have the ability to influence the landlord, especially around retrofitting those buildings for greater carbon efficiency. Where we have our own offices and looking at how we are going to evolve those buildings, and specifically taking that whole life cycle view of what is the best solution in order to maximise the efficiency of that building, whether it's looking at the light fixtures and fittings, the boiler optimisation, whether it's looking at ground source heat pumps and solutions along those lines. That's very much what we're focusing on within the Kier Group. Within each of the individual businesses, such as Kier Construction, they are working on their individual business-led strategies about how they are going to start to travel along these pathways, and specifically the key initiatives around fleet, site and premises that they're going to be focusing on and driving over the next year or so. So that's me. I'm going to stop presenting to allow the next presenter to share their slide. As Gordon said, any questions, please do populate them in the chat. I will be here for a bit longer and I will make a point of answering those questions. Gordon, have any questions popped up since I've been speaking?
Yes, there's a couple. I think one of them you've maybe already addressed, which was Kier's plans for net zero carbon in leased offices, and I think you talked about retrofitting, but from my perspective, if we achieve absolute zero carbon by 2039 as a business through scope 1 and 2, does that mean that we then assist our clients with their scope 3 targets?
Absolutely. So for our clients, so we represent our clients, one category of our clients' scope 3. So the fuel, gas and electricity that we use is that scope 3 category that says subcontractors and suppliers. So if we have got clients who are aiming to hit net zero between obviously now and at some point between 2050, then we absolutely have to address our scope 1 and 2 before they can claim having achieved net zero. Even if we achieve absolute zero, so we are emitting no carbon whatsoever and we're not offsetting, so we don't have that net balance, for our customers, unless they are able to achieve absolute zero across all of their carbon categories, they will still be in the net zero definition, if you like. But I think it's important to highlight that for scope 1 and 2, especially on the back of the discussions that have been happening at COP26, I think there's going to be new scrutiny around how much offsetting is going to be effectively permitted by different organisations. I wouldn't be surprised if we saw tighter legislation coming in around what activities actually count as effective offsetting. Whether offsetting must remain within UK borders or whether overseas projects are permissible. And I think I think there's going to be a really great encouragement to push businesses away from offsetting for scope 1 and 2. Because we all will have to offset to a degree for scope 3, simply because there is a technology lag between the intention that we have today, but what is feasible and what is capable, and the technology available to actually reduce those scope 3 emissions. There are a couple of categories in scope 3 that are particularly challenging, such as the embodied carbon contained within certain materials, and also the operational carbon of the product over its lifetime.
Okay, thank you. And then there's several other questions around plant on site and things like this, but there's a really good question here about how do we go about dealing with clients that have lower decarbonising targets than Kier?
So where clients have actually said that they're going to hit net zero by 2030. Yeah. So for me, it's a conversation with clients, because if we have got a client that sets a contractual a term around right, you know, we want this building and it must be built today to net zero standards, then as an organisation we must do absolutely everything possible to first eliminate and then reduce our carbon emissions as far as possible around scope 1 and 2. If we then have that residual bit left over, whereby just through a practical consideration, so for example, we have staff travelling to that site who use their own vehicle and they can't use an electric vehicle because they don't have access domestically to charging facilities, then we need to be having a frank and open conversation with our clients to say, we can offset this bit, we don't want to, it's not the right way to go, because we are just simply kicking the can down the road. And the one thing that COP26 has demonstrated categorically is that road is now very, very short. We don't have the time to keep kicking it down the road. It would be far better to take the absolute net zero journey the right way, rather than aiming for net, where you've effectively had to rely on offsetting.
Okay, thank you very much, Jo. Just conscious of time, guys, so can I maybe ask Stephen if he can now do his presentation on what Scottish Futures Trust about improving the learning environment for our young learners. Thank you, Stephen.
Okay, Gordon. So, Gordon, can you just confirm with me that you can see my screen?
Yes, I can.
Excellent. Thanks very much, both of you, for the presentation so far. I couldn't help reflecting, just as Jo was speaking there, that we really are at an incredible point on this journey. The fact that we're all here, the language that's being used, the level of ambition that's being talked about, and the fact that there are so many people willing to give up so much time for this I think it is really an amazing and unique point in time, and certainly something that I can't ever remember a focus on a particular subject like this in the past. So with that in mind, how does the challenges that Jo and Gordon have opened up, how might that land within the particular challenge of the learning environment in Scotland? So my name's Stephen Long. I'm part of Scottish Futures Trust with a particular focus on design and technical elements. I'm an architect by background. So if I'm trying to move my slide on, but there we go. Has that moved on, Gordon? Yeah, thank you. You're nodding. A moment of panic there.
Yes.
So for anybody who doesn't know, Scottish Futures Trust are owned by Scottish Government. So we're a public sector organisation, but our mission is to help to create world-class infrastructure for the people of Scotland. So it's a very, very succinct aim, but of course all sorts of complexities in achieving that aim. And no matter what the challenge is, I think whether it's, as Jo talked about, whether it's buildings or roads or whatever, they're all met. All of those challenges are met by teams of people, and SFT's role, whether it's with public sector, with private sector, local authority, design community, etc. Our job is often to either act as the oil in the wheels, or to act as glue, depending on what is the requirement of the day. So we operate in the gaps, and our job is to try and help make things happen. So within the learning estate, then, in particular, which is where my focus is within SFT, what's the problem? So going back a little bit, even if we can remember pre-COVID, the learning estate, obviously we've got thousands of children and young people every day within relatively confined spaces, and there's been an historic issue of the actual air quality in the environments within which they and their teachers actually operate, and that's been a known issue for quite a long time. We did a survey a couple of years back, and it was one of the top complaints from building users, which was the internal environment wasn't very good. At the same time as well, and this is a well-known issue, again, probably even pre the immediate focus on climate that we've got at the moment, people knew that the buildings weren't performing necessarily the way that they had been expected. There was a performance gap between what people thought the energy consumption would be and what it actually turned out to be. And of course, more energy consumed means more pollution in the atmosphere, which causes the climate emergency that we're focused on just at the moment. As well as those very real issues, there's the financial cost of using more energy than what you would have thought. And there's a societal issue that affects everybody whenever we face a climate emergency. Those things have been obviously around for a few years, and they were whenever we started out on this, the current phase of work in the learning estate. And then, of course, along comes COVID to disrupt the whole world in ways that none of us had really thought about before. And it has only made those challenges of providing adequate ventilation even more difficult. And of course, in many scenarios, additional ventilation means additional heat loss. So we're in a kind of perfect storm at the moment of extremely challenging conditions. So there's big challenges, but what can we do about it? And within this particular context, the SFT manages the Learning Estate Investment Programme on behalf of Scottish Government, and that's an approximately £2 billion investment within the learning estate in Scotland. And that carries on from the Schools for the Future programme that probably many people on this call have experience of in the past, which delivered well over 100 innovative projects across the whole country. So within that programme, the intention then is that government supports the improvement of the learning estate, whether that's through new buildings or refurbishments. And it's a real opportunity to not just to improve the basics, but also to drive innovation within that part of the public sector estate. Whenever we set out a couple of years ago to put some criteria around this, one of the most important things was to, as I said, was to address the issue of internal environmental conditions, and particularly air quality and temperature. And it seemed like a good idea at the time, and that was pre-COVID. It seems like an even better idea now to have focused on that particular issue, but of course it will perhaps come under more scrutiny just because of what we will be learning through COVID. So we set that as a criteria, and alongside that, because they're so intrinsically linked, to provide decent air quality, but also doing that with using a minimum of energy consumption. And we were able, because of the mechanism, the funding mechanism, to make that a monitorable figure, and it's linked to the funding that councils receive from government in use for 25 years. And that provides a very useful and ongoing focus for everyone involved, that this will actually be tracked and it really matters over the life of the building. So within that target then, just to look backwards for a moment or two, what we did was we had a pretty well blank piece of paper. We looked around the world to see what methodologies existed to first of all provide good internal conditions, because that has to be a prerequisite, but then that had also monitored the actual consumption of energy that was used in practice to deliver those excellent learning environments. And having done that trawl around the globe and collected as much data as we could, we came up with the best that we could find at that particular time was a bunch of schools in England that happened to have used the Passivhaus methodology to design them and to construct them, and those were in use, proven to have very low consumption figures, and importantly, very good environmental conditions. So using those as the kind of best proven examples, we averaged those out. We tweaked them for a slightly different environment, which might be the worst case that you would expect in Scotland, perhaps a highland or island exposure, and that gave us a single number, all-in energy consumption, as you can see at the bottom, of 67 kilowatt hours per square meter per year. So to make it comparable across different scenarios, we had to define that a little bit. So it's defined as the core hours that the building will be used. That's not at all to say that a building should have minimize its operational hours. Of course it shouldn't. It should be open as much as possible to get best use of the asset for community and for after hours activities. But we will monitor it in a consistent way, 2,000 hours, so that we can compare across the country over time. And as it says at the bottom there, that really importantly, regardless of the source of energy, whether it's a renewable source or heat pumps or so on, all of which are good things, that in the reporting, councils will tell us how much energy has been used in total, because that's a better reflection of the actual performance of the building itself. As well as what's in, it's important to define for the methodology what's out. So while these are all good things, they're not common to every single school, and therefore those are excluded from the calculations. EV charging was excluded a couple of years ago whenever we were putting this together, and I don't think any of us could have foreseen the impact that EV charging would have had. EV as a method of getting around would have developed over the years, and Jo spoke about that even in terms of their own fleet and site vehicles. The initial focus was on new builds, but of course it's really important to not forget about the existing estate, and I think this is a theme that is recurring through COP26. It's come out of the shadows, if you like. The talk about refurbishment, I think it was the poor cousin for a long time, but at the moment refurbishment seems to have come into focus. And it's a really interesting topic. So within the Learning State Investment Programme, where we do have some refurbishment buildings coming forward, it was really important to try and frame what the level of ambition should be for in-use targets, and also the level of funding support that government might give to those projects. Whenever we set out on this particular journey, of course, everybody said, how on earth do we do this? All refurbs are different by their very nature. They are bespoke, which of course is true. However, within that, you know, a school, a small school, a big school, there's only so much difference between those. They're not hospitals, they're not airports, they're not that different. So we set out to do, as I sometimes say, to find the corners of the cost envelope, and we used the Retrofit methodology to look at 4 different schools, 2 primaries, 2 secondaries, 2 historic, 2 non-historic, to see what the range of performance could be and the range of funding that would need to be required. And actually, having worked that all through, the programme now supports the same level of funding and the same level of ambition energy-wise as if it was a new build, or in fact any combination of new build and refurb in between. And hopefully that encourages new build projects to come forward more and more. So where are we now on that particular journey? The targets, as I say, are set for new build and refurb. We've got 37 projects that have now been identified, and despite COVID and the disruption that there has been on that, we've now got 3 projects that have actually started on site this year, which is fantastic achievement for the designers and contractors involved in those. Approximately half of those, the Passivhaus methodology, while it might have been the source of the energy target right at the very start, was never mandated, because there's a freedom to be creative and to look at alternative ways of meeting that energy target. But at the moment, councils have roughly chosen that about half of the projects that I've identified so far are using either Passivhaus or Retrofit, and the feedback has been that they like the end-to-end rigor and the methodology that goes around that. The other half are taking lessons often from that approach, but not necessarily using the whole system in itself, and it'll be interesting to see how that develops over time. So whether they are using Passivhaus or not, everybody's facing the same energy consumption target. And we're seeing that there are some issues around the design skills. People are having to challenge themselves. They're having to train in new new ways to deal with the challenge. Contractors and their subcontractors again are having to reskill. And there are issues around the understanding the costs and understanding the risks as we go forward to make these projects deliverable. But it's an exciting time to see these projects moving from conception into reality. So that brings us to where we are today within the programme. Looking ahead, then we've got an exciting year coming up next year, where 14 of the first two phases of projects will go on site next year, and both Kier and Archetype are involved in some of those projects, and it'll be exciting to see those going on site next year. There's a huge challenge, of course, across the learning estate to improve the condition in certain places, and we're hopeful of a phase 3 moving forward, perhaps in the coming months as well. So whenever we set out, there was a clarity of focusing on operational energy, as I've just been talking about, but things keep moving, and there's more and more focus, as Jo talked about, the holistic levels of looking at carbon, not just in the moment, but across the whole life of an asset. And those are elements that we are looking at, and we're working with other stakeholders and partners to work out the best way to move the programme forward to include the focus on, for example, embodied carbon, and importantly, what might the impact of COVID be in terms of design and of learning environments as we go forward. And I think that there seems to be a move, an understandable move towards more refurbishment, because that's a great way to reduce the whole life carbon. We're excited about having some of those in the programme, and I suspect there'll be more come forward later. So thank you very much for that, and I will hand over to Gordon or to John. Thank you.
Okay, thank you very much, Stephen. So I'm going to pick up now on the challenge of the existing estate and the case for an benefit informed retrofit plan. But just to link between what Stephen's been setting out and my talk, I'm just going to show you a picture here of Curry Community High School, which is one of those first phase 1 LEAP projects that we're currently delivering with Kier. It's at detailed design stage, starting on site next year, and also includes, as part of the community facilities, what will be Scotland's first Passivhaus swimming pool. But in terms of the sort of where we're at the moment, we know that Scottish Government has set very ambitious targets. We've just heard about the Scottish Futures Trust energy target in the LEAP programme, and the Net Zero Public Sector Building Standard for Scotland was published this year, setting out both operational and embodied carbon targets. And this has really highlighted the need for the existing building estate to be addressed in order to meet those targets. And UK buildings have a significant contribution towards the carbon emissions of the UK, a significant percentage of the total carbon emissions. And most of those are buildings that already exist. The new build estate will only be a tiny part of that going forward. So it really is a big challenge that we have to address. And the easy option, of course, is to offset or to just swap out fossil fuel boilers, gas boilers for electric heat pumps. But what this graph shows, if we did that, the demand on the electricity grid, which is shown here, would be many times the available grid peak capacity, almost 3 times the current capacity. And even with a growth in capacity right up to 2050, we still only have got about half of the requirement, and that's at the same time as the grid needs to cope with increased demand for electric vehicles, etc. So we cannot simply just change fuel source. We have to address the efficiency, the energy consumption in the existing building estate, and bring that down at the same time as changing fuel source. And just to Enefit, I should explain, is the Passivhaus standard for existing buildings. And what this graph shows is for domestic properties, the current profile of space heating demand in terms of kilowatt hours per metre per year of the existing UK estate. Here you can see what a typical new build to building standards would achieve, and here all the way through to that's Passivhaus new build and Enefit, two versions of Enefit in the middle there. So you can see just by how much the energy consumption would be brought down if we adopted Enefit. But the challenge really is the scale of the existing estate, and we working currently with the City of Edinburgh, looking at their entire existing estate of over 400 buildings scattered around the whole of Edinburgh. Where do you start with a estate of that scale and magnitude? Well, we looked first of all at the age profile, and a large part of that is significantly aged. And then you can see on the pie chart to the right the split of that into use types, a large part of which is schools, but there's a whole range of other community care homes, offices, etc. So quite a varied estate in terms of age and usage. So in order to start assessing this, we needed to take a holistic approach. We looked at the typologies across the existing estate, we selected a number of pilot buildings and then assessed those in order to project those out across an estate-wide analysis. So around a dozen buildings were identified, ranging from small Victorian nursery buildings through to 1970s school buildings and 1980s office buildings, a whole range to represent the wider estate. And then we undertook a detailed analysis of those selected pilot projects. We undertook air tests and some imaging. We did cloud point surveys to get full 3D models of the building, and then we undertook the PHPP, the Passivhaus planning package, detailed analysis in order to understand how that existing building was performing, and we compared that with measured data and found a very, very close alignment between the analysis and the actual in-use energy, which then meant here you can see understanding how the building operates. So to this existing Victorian nursery building would need to achieve Enefit would need to come in at under 25 kilowatt hours per square metre per year. Currently it's consuming 340, so many times that. But what the analysis allows us to understand is where that energy is being lost. So we can see 26% through the roof, 15% through the windows, 12% through the walls, 6% through the floor, etc. And so once you start to understand exactly where those issues are, you can start to come up with proposals to how to make improvements to that building. So the approach we took is starting off here with the existing baseline. What is the energy consumption and where is that energy being lost? The first intervention is simply to swap out fossil fuel to air source heat pumps. Obviously no reduction in energy, just a change in carbon. And then we looked at several interventions, heat source plus some minimum intervention, 2 levels of middle of the road with slight improvements in air tightness and ventilation and some insulation, through to full Enefit, where you're actually achieving the full Enefit standard. And you can see here 35% reduction in heating demand, 64, 66 through to 88% reduction in heating demand by taking each of those scenarios. We can then look at how each of those scenarios compare to various standards, such as the 20 different targets, current benchmark, REPA 2030 targets, and other targets that we want to set, and look at where the Scottish Futures Trust target fits in with that. So you really have to go most of the way to Enefit to get near to the SFT target in terms of achieving what's required there. And we can then sort of map out exactly what each of those interventions means in terms of roof insulation, ground floor insulation, glazing, wall insulation, ventilation interventions, from improvements through to full MVHR. So you can very clearly see the different levels of interventions required to meet those different reductions in energy consumption. What's really interesting is the assumption that seems to be around a lot, that you can solve carbon reductions simply by changing from fuel to fuel source gas to electricity. What you can see here is that currently the existing building with a gas boiler has got 19 radiators. If you swap out to heat pumps and don't do anything to improve the fabric, you need 77 radiators because air source heat pump runs at a much lower temperature. And it's only when you get through to full benefit that you can actually get back to a similar number of radiators. So 77, 41, 24, 24 and 12. So the impact of just changing heat source without assessing and improving the fabric is significant in terms of what that means. But the other thing this showed was that the running costs will double if you just simply change fuel source without addressing fabric improvements. But carbon and cost are important factors, but there are obviously other factors that need to be taken into account, such as the heritage impact, because buildings vary hugely, the well-being impact that Stephen has talked about very clearly in terms of the occupants and how any changes you make to the building will impact on them. So the question is how to quantify and how to visualize these various different factors that could or need to be taken into account when you're developing a plan for an existing building. So we produce these visualizations where you're looking at operational carbon, embodied carbon, running cost, capital cost, daylighting, overheating, CO2 ventilation, indoor air quality, moisture risk to fabric, and conservation heritage value. And then for each of the options, here we're showing do nothing, here we're doing a middle of the road 3B version, and here full benefit. You can visualize the impact that you're having on against each of those criteria. And then we distill that down to a total performance index where you can have a criterion weight and an impact on 4 key issues: carbon, cost, indoor health and heritage value. So having done this really detailed technical analysis, you can then extrapolate that across the entire estate or individual buildings to make informed decisions about how that improvement is impacting on the overall carbon target, cost, health and heritage value, depending on the relative criteria that you want to give to that as a landlord or as an estate FM provider. So I think this is a really radical piece of work by City of Edinburgh, because it's the first time that anybody's taken a really rigorous look at an entire estate to understand how then to address individual buildings within that, within a long-term plan to meet the required carbon targets that City of Edinburgh want to achieve. So I just want to briefly show you an example of a full benefit transformation of existing building. This is for the University of Cambridge, and it shows what you can do to a building if you take this to the level of full benefit. So it's an old telephone exchange building run as an office. Highly sensitive. It's not listed, but it's in a conservation area, as you can imagine, in Cambridge, highly sensitive. It's a new headquarters building for the Cambridge Institute of Sustainability Leadership. So I said it's in a conservation area. It's going to provide office, exhibition and teaching space. And they wanted this to be an exemplar of sustainability, as you would imagine, being a global leading institute. So the client here set some very ambitious targets: full benefit, BREEAM outstanding, WELL Gold, a circular office, bio-based materials, low embodied carbon, and a rigorous program of post-occupancy evaluation. So an ambitious brief from the client. So we undertook analysis similar to that, which I've just described at Edinburgh, where we used the PHPP, the Passivhaus planning package, to analyse compare the options that we had. So this is the existing media readings. This is extrapolated up to full primary energy consumption, and then here is the building improved to Enefit, Enefit Plus and Enefit Premium. Those are Enefit Plus renewables. The adoption for the project was Enefit Classic because it was a tricky building to add any renewables to, but you can see this affects a massive reduction in energy consumption compared to the existing building. It's a challenging building, some really complicated details to resolve, complex existing features to retrofit, thermal bridges everywhere, and a variety of different construction types, as you would expect from a building that's been added to over the last 70, 80 years. But that is the nature of what we need to address in industry in terms of retrofit to tackle those tricky details. One of the most interesting ones was window specification. The existing windows are sort of typical sash windows, very, very difficult to get the level of energy performance you need to get Enefit with triple glazing with windows like that. So we looked at a number of options and actually decided we'd like to opt for a very modern approach of a fully frameless window set back behind the brickwork. As you could imagine, that was a challenge in terms of planning and conservation, but we managed to persuade the planners that that would be an acceptable approach. You can see the existing building and the proposed frameless windows. What was fascinating was that our primary driver for this was reducing energy demand, as you can see, with different options on window design. But the added benefit was a significant increase in average daylight factor as we moved away from highly framed sashless windows through to frameless modern windows. So there's a huge benefit in terms of well-being in the building by taking a rigorous approach and working to persuade planners and conservation that a properly retrofitted building meeting future energy, climate, carbon targets has to be more radical and not just accept that things need to stay the same visually. Whole life carbon modelling here is showing an 82% reduction in the whole life carbon. Most of that is operational because obviously if we'd rebuilt this building, it would be a massive hit of embodied carbon, but by undertaking retrofit, we're minimising the embodied carbon in materials and achieving a huge reduction through the operational savings in use. The project, as well as a focus on carbon reductions and energy reductions, has taken a very sort of wide-ranging approach to the use of bio-based materials, adoption of a rigorous circular economy approach, reuse of existing furniture where possible, access floors, reclaimed lights and materials. So a really big focus on going beyond just meeting carbon targets and looking at true circular economy factors. So just in conclusion, there's a lot more support and guidance coming out now in terms of retrofit. Passivhaus Trust that I'm representing today has just published the Passivhaus Retrofit in the UK guide. Letty have released a climate emergency retrofit guide, and there's a lot of focus on this and a lot of support and guidance that can be accessed. So in conclusion, just changing the fuel source by swapping out, for example, gas boilers for heat pumps doesn't solve our problem. It does reduce carbon in the building, but it doubles the running costs. It creates demand that the grid simply cannot and will not be able to cope with. So fabric measures are essential to match fuel source changes. The question is how far to go. And what I hope I've shown today, that if you adopt the rigour of Passivhaus, the rigour of Enefit, you can develop what we're calling an Enefit-informed retrofit plan, which gives a very clear basis to make decisions that are technically informed. There's a lot of what I would say sort of people at the moment just adopting measures to improve buildings without undertaking that technically informed analysis, and I think it's really vital. And one of the great things about the Passivhaus analysis is it's highly accurate, and you can trust the outputs from it to give you a very, very sound basis for making decisions about how far to go. It doesn't mean every building has to be done to Enefit, but you can adopt the measures that the Enefit-informed retrofit plan guide you towards in order to make sound decisions for each building, or to project those decisions across an entire estate, such as the City of Edinburgh's. We've got a massive task ahead of us. If you just take the domestic estate in Britain, if we're going to meet the targets that politicians have set, we've got currently 35 seconds to complete each retrofit. We need 500,000 simultaneous retrofits of houses going on, and we probably need more than 2 million people in the retrofit industry, where we've currently only got 135,000. That's a massive challenge, but it's also a huge opportunity for our industry if we're going to transform to become a truly sustainable industry. It's a massive opportunity for us too. Thank you very much.
Thank you for that, Jonathan and Stephen, and also to Jo. There's been quite a few questions raised. I don't think we'll have time to answer them all at the moment, but what we will do is we'll prepare a list of the questions and our thoughts on their answers and circulate that around the attendees hopefully next week. But a couple of questions at the moment, guys, if I can. Stephen, maybe for you the first one. Got a question here about, I think it was your very first slide, which talked about the COVID and the letter C, and this the delegate is commenting that at the moment COVID is crippling their budgets, with mechanical ventilation running 24/7, windows being open all the time. Oh, sorry, my question's just disappeared. There it is again. Windows open all the time and heating on for staff who are cold, and then you're multiplying that over an estate. Do you have a view on how what we've been talking today, either through a Passivhaus solution or an Retrofit solution, that how that can be addressed?
I think first of all, it is obviously a massive and global problem that we've all been dumped into, and those of us around the world who live in climates where it gets cold in the winter are all facing that exact conundrum. How do you keep the air fresh and the air warm? We an SFT are involved in with the government in terms of assessing this scenario in different parts of the public sector estate, but particularly within schools, because there's such a big focus. But there are lessons that can be learned from that, obviously, to offices and to private sector businesses as well. I suppose the really important thing is giving people the tools to have adequate ventilation and appropriate temperatures. So I think it's fair to say that initially there was very much a mindset of throw the windows open, and because we have to have as much ventilation as possible. You know, maybe a year or so ago that was maybe the mindset, whereas going into this winter, certainly within the school estate, there's much more of an emphasis on enough ventilation that without dipping into uncomfortable temperatures, because both of those things are important to the health and well-being of the users. So one of the things that has been done, some of you may know, is that we have worked with local authorities to assess every learning, teaching and play space with CO2 monitors over the last couple of months to sort out the basics. So windows that were stuck shut, fans that were broken, and so on, to get ready for this coming winter. And those CO2 monitors will be used in conjunction with thermometers, to give users the tools to not end up in the scenario that the questionnaire the question is suggesting, so that you've got the tools to balance ventilation and temperature, so that we get through the winter healthily and comfortably, because human behavior will start to kick in. If you're too cold, you'll shut the windows and then you get no ventilation. So in turn, I suppose that's the short-term response, is that we need the tools to balance those two criteria, and that could be applied to whether it's domestically or a school or an office. It doesn't matter. The same strategy could work. In the longer term, I think that that controlling ventilation is the way to balance both the internal environment, whether it's for concentration or whether it's for COVID or any other infection. Balancing that air quality with heat loss is exactly what methodologies like Passivhaus and Retrofit are all about. So going forward, I think that is what they've always done. That's what we found was really impressive visiting the first Passivhaus buildings that I ever visited. That was what was impressive, the balance between not just low energy for the sake of it, but which of course is important, but low energy and excellent internal environmental conditions, temperature and air. So yes, I think going forward, Retrofit or Passivhaus or other methodologies that balance those two criteria, really useful, really useful tools. Probably more important than they were pre-COVID.
Can I just add to that, Stephen? One of the things that led us into adopting Passivhaus in the first place was monitoring air quality within our own school environments we designed, and we discovered really that it's very difficult with mechanical ventilation to get adequate, with natural ventilation to get adequate air quality. Natural ventilation sounds lovely, but actually if you call it what it really is random uncontrolled ventilation, it doesn't sound so attractive. And it is, you've just highlighted the very difficult challenge of balancing temperature and ventilation with opening windows, because in winter you will get cold air in. One of the great things we found in monitoring our Passivhaus projects is that you basically get very even temperatures at the same time as very good air quality. The CO2 levels you get monitored, measured in a Passivhaus building are below the level that the WHO suggests you should be at below to minimise COVID risk. So we can be pretty confident that the continuous supply of pre-warmed external fresh air and the continuous extract of stale air in a Passivhaus building is doing as much as you possibly can to minimise the risk of COVID. I think it's great to hear what SFT are doing to support the existing estate in being aware and being able to control that as best they can, but I would absolutely agree and suggest that the way forward is Passivhaus Retrofit in terms of being confident in creating a ventilation and comfort that minimise as far as is possible the risk from COVID and other airborne sort of diseases.
Thank you very much for that, guys. Another question for you, Stephen. I think this one's quite technical, but we'll see how we get on. When you suggest whole life carbon, does this deal with carbon reclamation after the life cycle of the building? And does this include carbon right from source, as in, for example, the tree felling through to the final build?
I think those are great questions, and I can honestly say I'm not an expert in that field. What that slide was really saying was that while we've made a good start in the learning state by framing operational energy, we're absolutely aware that we need to look at all of those issues that the question highlights. And I think one of the big problems in terms of whole life carbon assessment is, as Jo said, was where do you draw the line? So I think it's a fantastic question that we don't have an answer at the moment. The standard that Jono referred to has a suggested way of monitoring that, and we're in the process of working out what is the best way to perhaps bring that into learning estate projects. But as I think, as Jo absolutely said, it's where do you draw the line, because it goes on and on and on, and we need some kind of common definition, common understanding, so that people know what the numbers mean. Otherwise, it just becomes meaningless battling around of numbers that don't mean the same thing to each party. So no, great question.
Okay, thank you for that. I think there must be some quantity surveyors on the call, Jonathan. So a couple of questions for you. What is the estimated cost for retrofitting existing domestic and commercial properties in Scotland or the UK? With a follow-up one is about, is there any initial uplift on the capital costs for an Enefit project? What sort of percentages would be expected to uplift a project for an Enefit type project?
Okay, that's obviously a very pertinent question. I mean, the first thing I'll say in terms of a straight new build passive house project is our experience over the years is that if you focus on building in passive house from the very beginning, then you can achieve passive house for the same sort of budget as a non-passive house, and that's by rationalising the form and simplifying detailing and reducing energy systems to much smaller ones. You can pay for some of the extras like triple glazed window by saving money on other factors. So the evidence over many years is that you can do passive house for a similar capital cost as non-passive house. That challenge is much, much harder when it comes to Enefit, because obviously you've got an existing building, you can't optimise its shape and form, you have to deal with what you already got. So there will be potentially extra costs, but there will also be some savings too, because if you spend some more on fabric upgrades with insulation, but you end up with a much smaller heating system. So the example on the Enefit study we did for Edinburgh, if you just swapped out from gas boilers to air source heat pumps, you needed to triple the number of radiators and you doubled the running costs. By going on fabric improvements, you're actually saving on having less radiators and less impact on the services costs. But there's still a greater cost overall in terms of the fabric. So with Edinburgh, we're currently at quite a sort of critical moment in terms of we're working with cost consultants to put cost to each of those different levels of interventions that I described, from do nothing through to energy systems, different levels of retrofit through to full Enefit. And obviously that varies from building to building. So I can say that, you know, for a 1970s school, Enefit, full Enefit probably looks like a sensible cost. If you're going to retrofit the school anyway, to take it to Enefit is a relatively small additional cost. If you've got a listed Victorian nursery building, then the cost would be huge, or the heritage impact would mean that you couldn't do that. So the cost varies hugely. I couldn't give a standard percentage. We have to accept there is a cost. When you extrapolate the cost across the entire City of Edinburgh estate, you're talking about big numbers. And if you're project that into the future in a staged plan over 10, 20, 30 years, and you're looking at all the stuff that accountants talk about, like optimism bias, pessimism bias, you know, who knows where the current costs in the industry are going with the market volatility. It's not so much a finger in air, but it's some big sort of guesstimates being built into that. But what you can say for sure is that you're talking across Scotland billions and billions and billions of pounds to upgrade the existing estate to meet the targets that the politicians have set. And I think that is actually the big challenge for local authorities and for Scottish Government, is how we bridge that gap in cost in terms of finance. The cost will be greater than the running cost return, but the carbon emission reductions have to be met. So it comes then down to, how do we make those value judgments? Do we meet the carbon targets that we have to? And if so, how do we finance them? And I think that is the really big challenge that Steve and others at SFT and Scottish Government are going to have to be addressing as we move forward. So it's not possible to give a straight percentage extra. There is an extra. It varies hugely from building to building, but it adds up to a big number. That's a challenge for the Scottish Government, the UK Government, world governments. It's a massive challenge.
Okay.
Gordon, can I come in on that one just to briefly?
Of course, okay. Stephen, on you go.
Yeah, I think there's so much in this question, and it's almost, in some respects, the biggest barrier probably to reaching these ambitions, and it's good to now start to unpack that. As John said, that, you know, across the whole country, whether it's public sector, private sector, whatever, we've got to move towards this. So it's more a question of what's the best way to do it, because doing nothing's not an option. And there will be the full range, you know, from major building reconstructions, refurbs and so on, right down to minor interventions. And I think one of the things that we need to look at is, as each piece of building work gets done, regardless of the scale, is it a step in the right direction or not? So, you know, but windows will need replaced continually, they always do. So which ones do we use? Do we use the ones that step us towards net zero, or do we use the ones that don't really achieve anything? And one of the lessons I think that I've certainly learned over the last couple of years of looking at this is it's almost a case of do the next right thing. You know, it sounds a bit trite, but if a set of windows that are triple glazed costs 10% more than the ones that are double glazed, that might be the next right thing, that each of us needs to do. So I don't know if that helps in any way, shape or form.
Yeah, I mean, one of the things I'd just add to that is that the idea of the benefit-informed retrofit plan is that any decision you make about improvements to that building now or in the future can be made in the context of the guide of that plan. So yes, you know, if you're going to replace the roof, how much insulation you need to put in at that time. If you're going to replace the windows, to what spec. So you don't have to do everything now. You can actually step by step over a period of time move in the right direction. But each time you're making that decision in the light of a technically informed analysis, rather than choose this or choose that. It's informed by the impact it has on taking you in the right direction.
Thank you. Thank you for that. I'm just conscious of time now, and we've obviously got someone that's learnt something from this seminar today, because they're now talking about upgrading their house, and the intention originally was to take out an old oil boiler and put in a new air source heat pump, but they've been listening to what we've been talking about a fabric first solution, and they're now talking about upgrading their houses, their homes, building fabric, as well as carrying out the change in boiler, which is fantastic, because I think that's really what it is really all about. It's about a fabric first solution. But just on that matter, and just a quick response, guys, if you can, maybe Jonathan first. Are there any views on the benefits or disbenefits of an air source heat pump versus the ground source versus a water source heat pump?
Okay, I think it depends very much on your circumstance. If you've got an existing building, the easiest and cheapest option is always going to be an air source heat pump, and on many new buildings it's an easier, more cost-effective option. A ground source heat pump is extremely good option, but it obviously requires much greater capital cost in terms of having the tube pump that's going right down into the ground for the heat exchange within the ground. My understanding on larger projects, that actually is generally more efficient, and it's more efficient in colder climates, because obviously in the Highlands of Scotland, when the outdoor temperature is very cold in winter, the air source heat pump will be working much less efficiently than the ground source heat pump. So, but again, it needs to be assessed on each location. You can do a proper assessment and make that on an informed basis, balanced against the cost and the capital cost of doing that. So there's no straightforward answer. Both are effective, but each will be more or less effective depending on the building and depending on the particular location.
Okay, thank you very much for that. Just waiting for making me live, Jane, if that's possible.
You're live.
Thank you very much. So again, I'm just going to draw our presentation to a close now, and I'd like to thank the attendees for your contributions. We have said that there's been quite a few questions asked, and we'll collate them, do a written response and circulate them around to the attendees. Some of the questions are a wee bit political, some of them are more strategic in what the UK is going to do about its power, but most of the questions are excellent, so thank you very much for that. Finally, I'd like to extend my thanks to the hidden helpers in the background today, Jane Revell, Pete Banner and Jim Bennett, who've helped to make this a seamless-ish presentation. I'd like to thank our three presenters, Stephen, Jonathan and Jo. And finally, again, I'd like to thank you for listening and for your contributions with your astute questions. If you have any follow-up questions or would like to discuss any aspect of this presentation in more detail with any of our speakers, please feel free to contact me. My details are at the start of the Q&A function, and my email address is gordon.reid, that's R-E-I-D, at Kier, Kier.co.uk. In the meantime, I hope you have a great weekend, and let's all go forward to help make the built environment a sustainable industry. Thank you very much for your time.